Hello, everyone. Very excited to be here at Vox Days Bucharest.
Hello.
So if you are all here, let's start a guided tour of Kotlin for the JVM and...
Beyond.
Okay, so first, let's present ourselves.
Hello, everyone. I'm Yassine Benabbas. I'm a DevRel engineer at Worldline. I'm also a teacher and a member of the Lille Android user group. And about you, Ibrahim?
My name is Ibrahim. I'm a mobile software architect at Worldline also. It's a payment technology company. And I'm also a teacher on engineering schools. We both live in Lille.
Bonjour.
And we also have offices, Worldline have offices in Romania, here in Bucharest. So let's start. So first, to the audience, what do you think? What can we develop today with Kotlin? Raise your hand if you think we can do mobile. Of course. Web?
Yes.
Yes. Desktop?
Yes,
Also, of course.
Can we develop backends with Kotlin? Yes, that was what Kotlin was made for at the origin. And there are many more things that we can do with Kotlin nowadays. For example, we can also do data science. And that's what we're going to show today by leveraging the JVM and even other features that we're going to highlight or we're going to show how you can develop all of this with Kotlin.
So let's start. So first, let's talk about the milestone achieved by the Kotlin ecosystem. So it's already in 14 years for Kotlin. It's quite young for a language, but we both think that there is a promising future of it. So Yassine, can you share the first milestone?
Yes, so Kotlin was originally released as an alternative to Java as a JVM language for backend development because it brought null safety, conciseness in the code, domain-specific languages to allow to write very readable and clean code. But it expanded to other targets. The JavaScript target was added, so you can compile your Kotlin code to JavaScript. It also supported Android Studio, Android development. And the multi-platform nature of Kotlin began to become more and more mature with the release of the first beta of KMP. And it continues on this movement.
Yes, the second milestone between 2018 and 2020 was mobile and backend focused. Ktor library for networking was released, client server side. The the concurrent programming also was released with a coroutine approach. Kotlin was by default the language for Android. There is also the appearing of Jetpack Compose, declarative UI approach for Android first. And regarding Kotlin, the beginning of Apple interoperability just started. So just after, focusing between 2021 and 2024, really focused on multi-platform. It was the years of multi-platform. Compose multi-platform was released with different level of maturity to get UI commonly on a multi-platform approach. Kotlin DSL was by default for the Gradle build system configuration. Kotlin 2 was released with great features, and also we saw also Google supporting multi-platform libraries and having also a strategy for multi-platform usage regarding mobile. And Yassine, regarding the future, what's coming?
Yeah, only good things are coming. What we're seeing nowadays is getting more stability, more maturity in the different features of Kotlin ecosystem. For example, we're seeing the Ampere build tools, which allows to write very simpler build configuration files for multi-platform projects. There is the Klibs website that was released recently, in the recent months, that allows to browse and search for multi-platform libraries. It's equivalent to npm.js, for example, or Maven repo, but dedicated to Kotlin libraries, and so on and so forth. For example, the Kotlin to Swift export, which is getting more and more stable and more features. So, regarding the multi-platform aspect, can you delve into this, Ibrahim?
Sure. So Kotlin multi-platform, KMP, enabled the ability with the Kotlin language to to create a library that is commonly used with all the target mentioned here, meaning iOS, Android, desktop, and web. WebGS, WebWasm. So the library itself enabled to have common code, but also to be able to have specific codes for each platform and to be able to have a specific logic. On the top of that, you have also the Compose multi-platform library, being able to have exactly the same approach, integrating to KMP the Compose multi-platform library, enabling to have common views for the specific target. As you can see, the level of maturity of the support is different. It's stable for Android and desktop. It's in beta for iOS, and it's still in alpha for web. So let's now go a bit in a concrete architecture description. So basically, on a clean architecture, imagine that you're starting up with, you already have an iOS app and an Android app. It's a retail app, so basically you have the list, the catalog of your products, you have the description, the details of each product, you have the basket, you have the tunnel of payment, the payment tunnel. So basically you have this on both approach. You can just start right now having a KMP application where you embed both of your actual code. And if you want to add a new feature, such as loyalty, for example, you can start it up with the data logic and the business logic to start up your feature, requesting specific call in a common shared code based, and starting up slowly to have the features, actually new features, and also embed and migrate your actual features of native applications. So this is really interesting, and more you can have common code, multi-platform with a multi-platform approach, and you can revert if you need it for some, if you're not satisfied by the results. You can go further once you have a shared code base that is increasing. You can have the Compose multi-platform approach. You need to be strategic. For now, the status is quite different between the targets, but imagine you have FAQ, you have very simple views. You can already consider this to have a multi-platform approach. So have in mind also that you are using Kotlin also for Gradle build systems. So basically, once you're fully multi-platform, you have a fully multi-platform architecture, you're fully in Kotlin. Kotlin is everywhere. So we talk about specific code, how it works. So basically, it's based on the keyword expect, two keywords, expect and actual. Expect is on your shared common code, expecting a class, expecting a function, expecting different component of the language, and it's like contract-based. I mean, you are expecting a function, and once you do that, at compile time, it will complain if you're not actually have an actual declaration on each platform you are currently supporting on your application. So the actual, if you have a look to the actual implementation, here we get platform to get actually the version of the OS that is supported by your app. And you can see here that we are calling Android.os for the actual declaration of Android, and we are calling UI device. And you can notice that it's in Kotlin. So the UI kit is wrapped in Kotlin, and you are able to have some calls in Kotlin and have all the logic structure in Kotlin. So regarding the architecture, any Android developer there? So if you are an Android developer, you're not lost at all because it's clearly taking the Android architecture pattern. So it's quite clean architecture based. So basically, you have the lower layer are the data layer. You have also a non-mandatory business layer in the middle, and you have the UI layer. For the data layer, you have the data sources, which are where you are actually using your library for getting the file system, getting the network, and getting the database data. The repository is like the orchestrator of every data sources that you have to have some rules. For example, you want to, every 5 minutes to retrieve some data. It's the logic of it is on the repository. You have, after the stakeholder being able to prepare the data for exposing to the UI element, and UI elements are made with Compose. So what is actually here right now? Compose is available and stable depending on the platform, like mentioned. Navigation is available to be able to navigate between screens rationally. Resources management is also enabled in multi-platform since 2024. View models are available. You can also use some third-party library for user preference, like Ktor. It's simple file system-based storage. For network, we are using Ktor. And regarding the database, if you are just considering iOS and Android, there are plenty of solutions. If you are considering also having other targets, it's a bit under constriction, especially for WASM target. If you want some injection, you have also plenty of solutions. Coin is something to consider. You have concurrent programming available, and of course, if you don't want to follow the official pattern, you have alternative ones like Block with Decompose. So, just a word regarding Compose. So, what is Compose? Compose is a declarative UI approach standardized by Android, but now available for Compose multi-platform. Basically, you are declaring functions that are annotating with composable, meaning that you are describing a UI. So you are describing a UI using other composables that are already on the SDK or you have created by yourself. And here you can see a screen on the right. We have a box, we have card, we have modifiers able to modify the view and adding paddings. And then you have your basic component, text, buttons, and so on. So how it is possible to have this multi-platform? It's thanks to Skia and the Skiko implementation behind for the specific target to be able to render correctly what's coded. So you have a bit of an overview regarding the architecture. Let's have a look to the final product. We have a use case here. It's a simple basic quiz application. You can scan it. You can have the web target available and can see that the WASM target is working on your phone. For Android, it's in the latest version that is available. If you have an oldest version of Safari, it will not work. So we have basically three basic screens. So let's have a look. We have a quiz screen with one button. We have the question screen that is looping to the data, the question data, and at the end we have the score screen, getting the scoring and getting the feedback about your score. So now we will have a demo of it. So how it works, how to code that, to code this application. So basically, we're using a data layer where we have a repository. We have multiple data sources. We have the one quiz API data sources that is retrieving, thanks to Ktor, the data. We have also a mock data source able to get some fake data if we don't have any connection for the first time, for example. And we have also the Ktor data source that is able to store in a multi-platform way the data in it. So we have also, I have to mention that on the application we have also a monorepo approach where we have also a Ktor server able to get to retrieve the list of questions. So let's have a look how it works. So here is the IDE. One disclaimer, here it's Fleet. Fleet is just discontinued, but now it's fully Android Studio that is supporting Kotlin multi-platform, but it's still the same architecture. So we have so we are using Gradle basically here, and we have a Gradle module that is called Compose app, containing of all your target, and you can notice that you have here a Compose target also that is available. So here you have all your target on the Compose app, but you have also an iOS app module being able to have all the specific code of iOS with the Xcode project for who knows. And you can see here that finally the composable views are encapsulated in a view controller, and the view controller is added to a SwiftUI view, because for now SwiftUI is not supported. For the desktop one, you can see that you have a simple Windows where actually you can able to declare your root composable. On the activity is exactly the same. We have the app composable that is able to be seen because automatically Kotlin multiplatform integrates the library to your targets. And for the web, you have a viewport able to understand exactly the same way the composables, and the same for the view controller. So this is how finally the composable views are able to be used in your native code. So now let's deep dive regarding the architecture. So we still have the Android architecture pattern. You have the data classes, the data sources, the quiz repository, the screens, and the root of the application. Let's have a look to a screen. So a screen, basically, it's a composable view. You have also a preview of the composable that is able to render with the icon you just see here. Let's have a look. Here you have a basic card, columns, and the preview can be seen on the right. So after seeing a basic view, how to navigate? So to navigate, simply you go to the root of your application and you can use the navigation host. The navigation host is the heart of your application, getting the roots of each application. Notice that here the roots are declared with strings, but it's no more the case now with the upgrade. It's type safe now, and we have real objects behind the roots, declaration and arguments. Then, we have the three roots we just described previously, and you have also access to the navigation controller on the nav host. You can inject it on your screens, but here I decided to have some callbacks and having all and mastering the navigation directly by passing to the composables the callback. So now let's go into the view model. So the view model is really simple here. We have only one for the whole application starting up at the beginning of the navigation host. And here we had all the repository, and at the instantiation of it, we just try to request to the repository to retrieve the data. Inside the repository, you have the three data sources we mentioned. So we have the API using Ktor, Ktor for storage, and the mock ones, and the update quiz that is called. Just check if it's more than 5 minutes, requesting to the network. If not, just getting all the questions for the database, or if there is no question on the database, getting the mock. So let's go now in a data source. So here it's the data source for retrieving the network. It's Ktor. It's DSL style declaration of the configuration of the HTTP client, and then we made just a simple get to retrieve the data. And we use flows, Kotlin flows, to be able to consume the data. The Ktor data source is the same approach, but for the preferences. So we get the function for getting and storing the quiz. But you can notice here that we used get Ktor for instantiate the Ktor, and we have an expect keyword here, and it's exactly the way to bind finally the specific implementation of the Ktor. So for each target, we are declaring separately the Ktor with the actual keyword. So here it was for WASP. Here it's for iOS. So we use NS File Manager to be able to get the instance of the Ktor. The same here for the JVM, and the same for Android by using also the path getting from the Android context. So basically, this is what we have. Just some remarks regarding the build system itself. You can, for example, with Ktor, declaring your libraries that will be used in the common code, and then you need to declare each libraries. So depending on the implementation, but here for Ktor, you declare each library that will be used on each target source set. So I think this is it. Now we can start just the rendering of it. So for desktop, we have the desktop version. We have also the iOS one, the Android one, sorry. So just a remark, also, some of the target needs to be configured and with the build configuration, you are able to override some parameters to be able to start up correctly each platform. So we have the iOS one, and the last but not least, the web target with WASP. So I think this is it. So just some quick feedbacks regarding the technology. So regarding a focus regarding the tooling, so KMP is improving a lot. iOS still getting some huge improvement regarding his integration, but also regarding getting the loggings and making more easy to debug from Android Studio. We have also some improvement between the version regarding the conciseness of the build.gradle to have less boilerplate, more accurate configuration, and we expect more with Ampere build system. And there are also a huge improvement regarding the IDE. So on the roadmap, official roadmap, it was supposed to have a new IDE based on Fleet to be able to be the next, the official KMP IDE. But it seems that the strategy changed a bit because we have two news that just comes. First, Fleet was now deprecated for the KMP usage. Android Studio, just on the latest market version, is now supporting natively without adding a plugin KMP. And we have also hot reload with the later version of Kotlin that is available for the desktop target to be able to have live updates regarding your code. And especially for building animations, configuring the UI, it's really convenient. Regarding architecture, for me, the main effort that is we're all waiting for is the web target to have more maturity and have also compose table for each target. So I think we make quite a guided tour of KMP and the front end with Kotlin. So Yassine, can you share with us what's new in the backend?
Yes, of course. So as you have seen here, just to precise, Kotlin JVM was used to render the desktop app. So you see how Kotlin takes advantage of the JVM to achieve these kind of results. But now let's go to the backend side. So as we have seen during the presentation of KMP, thanks to the large supports of targets in the Kotlin ecosystem, we have a wide and large choice of frameworks to develop backends. So you have what we call the pure JVM frameworks, meaning that they are frameworks made and tailored for Java and the JVM. And you know Spring Boot Quarkus, very stable, very mature. And they support officially Kotlin. So when you create a new project in the official website, Spring Initializer or Quarkus Starter, you can choose Kotlin as your language. And you can take advantage of some Kotlin features, null safety, DSLs for some libraries. So it really improves the developer experience in that regard. You have pure Kotlin frameworks. So they are frameworks that take advantage of the Kotlin language in its full capacity, meaning that you use all the language features, mostly the DSL part. We'll show an example later. But they can also run on the JVM. Some can also run natively without requiring a JVM. That's why they take full advantage of the Kotlin ecosystem. And if you want to be exotic, you can also try Kotlin JS or Kotlin WASM frameworks. Since Kotlin compiles to the JavaScript ecosystem, you can write backends, Node.js backends with Kotlin. So it's a little bit exotic, but it works, and you can try this out if you want to have some fun. Or you want to struggle or suffer a little bit. It depends on the, on the point of view. Regarding case studies, there is the official Kotlin website which references some case studies of companies that switched or use Kotlin for their backend development. And usually, or most of the time, or all the time, they have good feedback, especially because the Kotlin brings concise code, better developer experience, null safety, which eliminates a lot of errors. And we even got some feedback from colleagues in Wordline, which developed the Wordline conversational platform, and they use Kotlin, and they're very satisfied by using it. They even use the exposed library, which is a data access library. We're not talking a little, much more here in this presentation, but it's an alternative to Hibernate or similar libraries, and it's also very powerful, thanks with the feedback that I got. So this is the application that my colleague presented. Let's add some other backend awesomeness to it. So we developed another Ktor server, but this one now collects the results. So every time you complete a quiz, the data is sent to another server, which so digests all the data and provides front applications to render the graphics of the results with some statistics. So as you can see here, there is a graphic, so there is some data science aspect to this application. We'll cover this later. But for now, let's focus on Ktor. So Ktor server is a state-of-the-art server framework, meaning that it achieves all the tasks that we want to achieve from a backend server, thanks to its plugin support, which allows to add new features to the existing, to the base framework. It's free and open source, developed by JetBrains and maintained by or with the help of the community. And it takes advantage of the Kotlin language. As you can see in the code example, it's a DSL, domain-specific language, where you define your route through a function that calls other functions. But thanks to the Kotlin syntax, you don't see this, but you see this as just a chaining of objects. But there are functions that call each other. But this is hidden or very readable to us thanks to the DSL feature. So this is a demo of creating a Ktor project. You can go right now to start.ktor.io. And it looks like Spring Initializer and similar websites. The UI may change because it evolves over time. But the idea is the same. You create your project, the plugins. You choose the engine, which is the part that handles the HTTP stack. And then you download a ready-to-use project that you can open in your IDE, VS Code or IntelliJ. And then when you open the project, you can develop your application. And you can develop a lot of things. So in Kotlin, the CSS can be written in Kotlin. The HTML can be written in Kotlin. Everything, you can write everything in Kotlin. Thanks to the DSL, the syntax is very similar. Even the documentation. So there is a plugin which allows to generate the OpenAPI documentation. And you can write the documentation in Kotlin DSLs. So no annotation at all in here, just DSLs. And here you can see some HTML written in Kotlin, because the DSL syntax fits well with the structured syntax of HTML. And here is the export of the graph. So the library generates an SVG that we render. And once we're ready, we just run our Gradle project. Hot reload is supported in Ktor. It's a state-of-the-art server framework. And you see this. So there is no data. That's why the graphics are empty. The JSON file is empty. But you see the idea. It's a REST server with some server-rendered pages. This is the Swagger page, which is generated by the plugin. And you see that the documentation that we wrote by hand is available, as well as all the other routes that have been explored and detected by the plugin. So that's a quick tour of Ktor. Please give it a try, and you see how we can leverage Kotlin to develop backends. So let's talk now about Kotlin for data science. So for me, when I say that the Kotlin language is compatible with data science, is by providing 3 basic features. First of all, is the support of a great IDE with developer experience or Jupyter notebooks. So Jupyter notebooks are great for data scientists because it's a file that contains markdown, blocks of markdown, blocks of code, and the result of the code, the output of the code. It's great for data scientists because they just need to run their blocks of code. They have their documentation next to the code. Even for lectures, as a teacher, I really like using also Jupyter notebooks whenever I can. And one great thing about Jupyter notebooks is that they support every language as long as there is a kernel for that language. And fortunately for us, a Kotlin kernel is available for Jupyter notebooks. So you can execute, you just need to install it with pip install the Kotlin kernel, and you can run Kotlin code from Jupyter notebooks. So this is the first aspect. There are 2 other things that we need to have to be able to be a data science language, is libraries. Namely, a plotting library, which is Candiv in our case, and a data manipulation library, which is DataFrame. So it's a high-level data manipulation library that allows you to manipulate data in a simple way, as you can see here, thanks to, as usual, Kotlin DSLs. You can add columns, perform computations, filtering, and so on. So let me show you now how I developed the graphic in the server. So, like without Jupyter notebooks, what we would have done is to write. So you write the code, you run the server, you open the web page, you see the result, and then oh no, it's not what I want. So go back to the code, develop again, wait for the server to restart, go back to the page again. So it's really bothering. It's really cumbersome. We don't want to do that. We want to be faster. So what I did is that I created next to this project a Jupyter notebook that contains only the graph, only the bar chart. And I developed it with some sample data, because with Jupyter notebooks you can have also an HTTP client that can download data, like download data from the server. So you can download data or provide your own test data, develop your bar chart, and iterate very quickly on it. And once it's ready, you just copy-paste the code into the server code, and then you're ready to go. So that's also a very great use case of Jupyter notebooks, is to have a kind of a sandbox to experiment, to try with stuff without having to rerun a whole project from scratch. So we provide another demonstration in this presentation. This is a QR code if you want to scan it to check it out. It's the website that gives statistics of the different answers of the quiz. And it's a server-generated page. So it's basic HTML, but the HTML is defined in Kotlin. So here's a demo of what you can see as a rendering in your browser. So the Candy library can generate graphics into SVG. That's why we get these beautiful charts as a rendering. So this is a quick demo of Jupyter notebooks. So this we are in VS Code, just to show that it works also on VS Code if you prefer to use this IDE. So you have your Markdown. You have your Kotlin code, you write as usual, and once you're ready, you can press a button to render the Markdown and to execute the code, and you see the result below. Now let's switch to IntelliJ to show that it works on IntelliJ Ultimate. There is better support for now for Kotlin language. You have all the Kotlin language features, suggestions, and so on IntelliJ Ultimate. And when you run the code blocks, you see the output below each code block. And the output can be of different types. It can be text, it can be image, graphics, it can be interactive also. As you can see in this graphic, when the user hovers over the graphic, you see some tooltips. And one interesting thing about Jupyter Notebooks is that you can modify just one code block and rerun just this code block without rerunning everything. So it's also faster when you want to iterate over small chunks of code, and if you want to demonstrate stuff. So now we're ready. We finished playing around with our code, Jupyter Notebooks. We save them. We save all our notebooks. We push them into GitHub. And let's see what we see on GitHub. So that's also one interesting feature of Jupyter Notebooks, is that they render very well on different applications, such as GitHub. So even for lectures, it's a very great way to share lecture notes to students. As you can see here, the data frame is very well rendered, and so on. So yeah, please take, so this is an example of some sample data that we provide. You can even implement HTTP calls to call a server to test, to play around with the result of a server as any usual data science application. So that's it for the demo for Jupyter Notebooks. Since this is a Kotlin talk, we need to talk a little bit about the language. So I discussed with Ibrahim, I convinced him that we need to have at least 1 or 2 minutes for the language. Thanks, Ibrahim. So I just want to highlight 2 things. One feature that is available in the language, which is called explicit backing fields. Which is a feature which allows you to expose a property, but in a more restricted type. So this is the normal syntax without taking advantage of this new feature. So you have a mutable list, so a list that you can modify, but you want to expose it as a list which cannot be modified. Because in Kotlin, Kotlin has native support for immutable and mutable list. So a list is immutable by default. So for immutability, that's a great thing. But if you want to have a more concise syntax, you can just do this now, thanks to the field contextual keyword. Contextual keyword means that it exists only in certain situations. You can declare your public property, which is a list, immutable list, but internally it will behave as a mutable list. So internally you can modify it, but externally no one can touch it, which is called explicit backing field. And there is a link of the feature if you want to see how it got released. There is one feature that I really like, which I want to see released. It's still in discussion. It's still in development. It's called collection literals, which allows you to define lists and collections in general in a more concise syntax, similarly to what you do in Python, for example. And there are many more features. And what's good also is that everything is public. You can track them in Kotlin Keep GitHub. In social networks or in the uTrack, also in the Kotlin Slack, where there is a great community. If you need support or if you need to discuss with the community, the Kotlin Slack is a very great place there. So please take a look. And that's it for this part. So I think we can conclude, Ibrahim.
Sure. So we made the guided tour of Kotlin. So the question, Yassine, for our audience is it time to onboard?
Yes, of course, there has never been a better time to onboard, as you have seen during the presentation. Kotlin has achieved great milestones. It's getting more and more stable, more and more mature. The ecosystem is comprehensive. You can do everything in Kotlin. There are even things that we didn't show, such as infra-as-code, for example. And the backend frameworks are largely available and they are mature. So Node.js is a little bit a special use case, but other than that, everything works well and is mature. And how about you, Ibrahim?
As an Android dev, for me it's the first time. I'm really delighted to be open to other platforms. DSL style is everywhere. You're not lost. You're just improving your Android skills. So it's really a delight to make backends now, data science, and much more. Just few words. First, Yassine mentioned it. There is case studies, and we have ours at Worldline inside the JetBrains website. So it's a retail app made by some colleagues in Spain. So don't hesitate to have a look to case studies. It's really interesting to have other companies' feedbacks. And last but not least, we have 2 open source training, one regarding Kotlin language itself, and the second one regarding KMP. If you're just starting and want to start Kotlin, just don't hesitate to go there. It's a good starting point. And for those who's already a Kotlin expert, don't hesitate to create some issues there and contribute to this those open source project. Sorry. So thank you for your attention. And
thanks, everyone.